Right now, about 340 miles above Earth, moving at over 17,000 miles per hour, the Hubble Space Telescope is silently orbiting, capturing light from the farthest corners of the universe. It has given humanity some of the most breathtaking images ever seen. But here's the surprising truth. Those colorful, iconic pictures are not what Hubble directly sees. Even the black and white frames that make up those final images are processed. So what do completely unedited Hubble photos look like? And does that editing make them fake? The raw images captured by Hubble are publicly available online. When viewed in their untouched state, they look nothing like the polished pictures often seen in magazines or documentaries. Instead of brilliant color and sharp detail, the original frames appear dark, flat, and unremarkable. But there's a reason for this. Hubble is not a conventional camera. It cannot simply snap a photo of the cosmos. Instead, it functions as a scientific instrument designed to collect faint light from some of the most distant regions in the universe. To do this, it uses a system of specialized filters that isolate narrow slices of the spectrum. Each slice is captured in black and white. Later, these separate frames are combined and processed to create the color images widely recognized today. But why do the raw frames look so dull? The answer lies in how cameras and human vision differ. When any digital sensor captures light, it converts it into numbers. More light equals a larger number. But human vision does not work linearly. The eye perceives brightness on a logarithmic scale, meaning it is far more sensitive to faint light than to bright light. Computer screens mimic this perception. As a result, when raw astronomical data is displayed without adjustment, the details remain buried, making the image appear dark and lifeless. Those details, however, are not missing. They are hidden within the data. By stretching the brightness values, the faint signals of stars, dust, and gas begin to emerge. Each adjustment reveals more structure, transforming what looks empty into a rich, complex landscape of cosmic material. Unprocessed Hubble images also contain imperfections rarely seen in finished photos. White streaks caused by cosmic rays striking the detector, dead pixels, and gaps created by the telescope's dual-sensor design are all common. These flaws are corrected during the calibration process, which also removes noise and prepares the images for assembly. Thousands of individual frames may be stitched together to produce a single final image. This leads to one of the most common questions: are the colors real? The answer is both yes and no. In some cases, the colors are close to what the human eye would see. But often, especially in famous images like the Pillars of Creation, colors represent specific elements. Sulfur is assigned red, hydrogen is assigned green, and oxygen is assigned blue. This process is known as false color imaging. While the term may sound misleading, it is not meant to deceive. The colors are not arbitrary. They carry scientific meaning, revealing the composition and structure of distant objects that would otherwise remain invisible. If someone were to float alongside Hubble in space, the view would be far less dramatic than the images suggest. The human eye cannot detect such vivid color in low light and cannot perform long exposures the way a telescope can. Most of what Hubble observes would appear as faint glows or nearly black sky. But that does not make the images fake. They are representations of real data, stretched and enhanced to reveal what exists beyond the limits of human vision. The untouched frames may seem empty at first glance, but within them lies the story of stars being born, galaxies colliding, and the universe evolving over billions of years. Processing does not create this reality. It reveals it.